Hello everyone. Today we will solve a problem from Baltic Way contest 2024, problem number 7. This is a combinatorial problem. You are given with 45 cross 45 grid. So here is the diagram, and the central square which lies on the 23rd row and the 23rd column is removed from that. Now the question is, just using 1 cross n and n cross 1 tiles, so which will be a horizontal or a vertical n-celled tile, you need to pave the entire structure. What's the meaning of paving? You have to cover all the unit cells using this without any overlap, and these unit cells should not protrude out of this structure, ensuring that for what values of n can you pave the structure. Before getting into the solution, I will be briefly discussing about Baltic Way contest. This is a contest conducted for the countries around the Baltic Sea like Germany, Norway, Sweden and so on. This contest is organized in commemoration of the peaceful demonstration for the independence of the Baltic nations. You can get the access of problems and solution of past year questions from the link given in the description. You may be also eligible to participate if you're from those countries. Let's get into the solution. I once again remind you of the question. You are supposed to find the values of n for which it is possible to pave the entire structure in which the central square is removed with 1 cross n and n cross 1 tiles, that is horizontal and vertical n length tiles, so as to pave the entire structure without any overlap nor without any protrusion. So you should not waste any of those cells, and you should not also overlap them. So this means there should not be any square coming on top of the central one. Let me give you a quick example. N equal to 1 works. It's a simple reason, because each cell can be paved without any overlap. By just following the column number and the row number, you can keep on arranging the tiles and cover the entire structure. You just need to skip the central part. Let's go and think beyond the values beyond the trivial values. Suppose to pave the entire structure, we need k of these cells or k of these tiles, then the total number of cells would be k times n. Now this should be equal to the total number of cells in the structure, which is 45 times 45 with one central square removed. So I am subtracting 1 from it. This implies kn equal 2024. Now we get a necessary condition. N must divide 2024. This helps us to narrow down the possibilities a lot. We are just going to work with the divisors of 2024. Just a quick calculation, 2024 can be factorized into 2 cube times 11 times 23 in its canonical prime factorization. So the possible values of n are 1, 2, 2 square, 4 and 2 cube, which is 8, or 11, or 11 times 2, 22, or you could have 23 and so on. We will prove all values above 23 are not possible. So as we saw, the possibilities for n starts from 1 and goes to 2 and then to 4 and then 8. We have 11 and we had 22, we had 23 and so on. Let us consider the tiling of the cell immediately to the left and immediately to the right of the missing central square. Suppose you consider the value of n to be greater than 23. We know the size of this horizontal element is 22 and this one is also 22. So in order to pave this, I cannot have a horizontal tile that is containing this cell, because that will enter the missing central square. Hence, this must be tiled by a vertical tile, like a n cross 1 tile. So since n is greater than 23, you must have at least one cell above the cell that is immediately to the left of missing square. Similarly, this square would also be blocked. Either it is paved this way or it is paved like this. Whatever be it, the square just above the green one, that is just above the cell which is immediately to the right of missing central square, will also be blocked. Hence, if you think about the paving of this one, which is immediately above the missing central square, you will not be able to pave it with any n cross 1 or 1 cross n, because n cross 1 do not fit here as it's greater than 23, and 1 cross n clearly cannot pave because that will lead to some overlaps. So any n greater than 23 cannot work. We must have n less than or equal to 23. So this is the first conclusion. So then, is 23 possible? Let's come up with a configuration. Consider this block which is of size 23 cross 22. This length is 23, this length is 22. So this block is considered. Similarly, we consider this block of size 23 cross 22, and likewise we will pave the entire structure into 23 cross 22 boxes. Now this has lot of stuff embedded in it. You see, the entire structure is paved now. There is no remaining unit cell that's not in the pavement, that is not in the structure covered by these 4 cells. So if you focus on the length of 23 vertically, you can place 23 cross 1 vertical tiles and pave this one rectangle, piece of rectangle out of the 4. So likewise, you would need 22 such vertical tiles, and over here 23 is horizontally covered, so we will need horizontal tiling like this. All of them are horizontal. Over here we would need vertical tiles, and over here we would need horizontal tiles of length 23. And this way we cover the entire structure and our paving is done without any overlap nor protrusion. Alright, so n equal to 23 works. What about n equal to 22? Instead of considering vertical, you may replace them with horizontal, and horizontal tiles are replaced with vertical tiles, and the length 23 should be now converted to 22, and that will entirely pave these squares in a similar way but in the opposite orientation, because each rectangle is of dimension 23 cross 22. So now we are thus covering lengths of 22. Alright, so 22 is possible, 23 is possible. Interestingly, if a multiple of a number is possible, then that number is also possible. Or in other words, if a number m, if you can pave the entire structure with a number m tile, then you can pave the structure with any divisor of m dimension tile. What's the reason for it? Well, in the case of 22, we had a single block of length 22. Now you just have to dissect it into blocks of 2 or blocks of 11, because then all the tiling will now be based on that. So 22 can be dissected into 11 twos, and it can be also dissected into 2 11. So therefore, that satisfies the criteria for paving the entire structure. This implies 11 and 2 are done. N equal to 1 is of course done because it is a divisor of every number. But for proving or disproving 4 and 8, you cannot use 22, because 4 is not a divisor of 22. It leaves a remainder of 2. So how to think about 4? Well, we have to think about some contradictory arguments. Once you try attempt tiling it, you will see that in whatever orientation you place, you won't be able to cover the entire structure. So let's see how this can be performed. Alright, now our concern is n equal to 4. You should also understand, if I disprove for n equal to 4, that means if I cannot tile it with 1 cross 4 or 4 cross 1 tiles, I will end up disproving for n equal to 8. The reason is the backward statement that if n equal to 8 is true would imply n equal to 4 is true because 4 is a divisor of 8. And we will get a contradiction. So if I attempt disproving n equal to 4 and succeed, then it will also imply n equal to 8 doesn't work. We will follow a method called as coloring the cells. So coloring cells are analyzed when you have complicated structures like missing one tile or missing some corner tiles, like that. Colors have a pattern intrinsic to it, and that pattern arises a contradiction when done in a larger scale or counted in a different way. So let's have a closer look. This idea of coloring the tiles for contradiction can be used in multiple circumstances, particularly in Olympiad combinatorial problems. These are widely used. So we have multiple rows. So in fact, we have 22 rows before the middle row, and 23rd would be the middle row, and you have 22 rows beneath the middle row. I am going to color row wise. Mind you, there is no one way of coloring the cells. You can color alternatively like a checkerboard, or you can color alternate rows in one color, but I am going to color 2 rows in one color and the next 2 rows in another color, and then the next 2 rows in the first color. So it's like BB, white, white, black, black, white, white, black, black, and so on. The reason why we do this kind of coloring will be obvious when we reach the solution. So you have all black cells, and white and white. This is a method of analyzing, by the way. There is no intellectual, or I would say, there is no theorem that is asking me or requiring me to input this kind of colors. I'm just using it for my analysis. So you have 2 Bs followed by 2 whites, 2 Bs, and so on. So what would be the color of the middle row? You see, every 4K plus 3 and 4K are white, and every 4K plus 1 and 4K plus 2 are black. 23 is of the form 4K plus 3, which means it will be in white color. So you have white and white. 24th row will also be white, but the row before that would be black. Now again you have black, black, and so on. 44th row would be W, and 43rd row will be W. 45th row will be black because of the form 4K plus 1. So this is done with row wise coloring. What's the color that's missing here? Since the entire row is white, the missing cell will also, one white is missing. The missing cell will also be white, as the entire row is in white. Let's count the total number of blacks and whites distributed. You see, here it's 45, here it's 45, so it will be 90 in total. And 2 white rows, 90 in total. So you could see all in the entire thing, like you have 2 whites together count to 90. So it is even in number. Likewise, all 2 rows combined would give you an even number, but the last black row would add up an odd number to the total number of black squares. So the total black will be B total would be an odd number, counted row wise, because 2 Bs 90, 90, 90 and so on, but the last B would be 45, which is an odd number. W total. Well, Ws always occur in 2 rows together, so it's even and it is missing exactly one unit cell and therefore it will also be odd. So this is how we did the coloring. Now let's analyze a 4x1 or a 1x4 tile when placed on the structure, vertically or horizontally. It is going to cover 4 blacks or 4 whites horizontally, and vertically it is going to cover 2 black, 2 white, or it is going to cover 1 black, 2 white and another black. So in either way it is going to be some permutation of 2 black and 2 white. So horizontally it's even for both, and vertically also it's even for both, which means if I am able to tile this entire structure, the total number of Bs will be even and the total number of whites will also be even if I am able to tile it with 1x4 or 4x1 tiles. And I knew that this is the truth. Total black unit cells is odd in number, so is the total number of white squares. And I would end up with a contradiction. Hence, it's never possible to tile this structure with 1x4 and 4x1. This is the use of coloring the cells, and the way I colored magically made any 4x1 or 1x4 tile to contain even number of blacks and whites. So you ensure that and you arrive at a contradiction. So you cannot directly think that this is never possible. You first have to attempt yourself for lower dimensions, keeping the congruence with respect to 4 the same, like 4k plus 1 cross 4k plus 1. Try to tile. If you're not able to, then probably conjecture it and use coloring the cells to analyze and end up getting a contradiction like this. Maybe again for a lower dimension. Later you can think of 45 cross 45. This is usually the approach, so you can also try in this way. If you get your own ideas, please put out in the comments, we will discuss it. Thank you for watching everyone. Bye.